What's up? I am John Vaughn. You're either watching this on Facebook or on YouTube. Either way, you can either be my fan on YouTube or Facebook. I'll accept you either way. This is going to be a pretty simple tutorial about something that if you like Arduino or if you like electronics, you should be pretty interested in. It's going to be a tutorial on I2C communications. And what we're going to use for I2C communications is we're going to use this right here, which is a GY26. It's a compass, or otherwise known as a magnometer. We'll call it a compass. And we're going to use this thing right here, which we just got in the mail today. This is the GY45, which is a triple axis accelerometer. It can also be used as a compass, but we're going to use it as an accelerometer to actually make sure that we're moving in a particular direction. And why we're doing this is for a robotics project that we have. I'm building this guy right here, building this robot right here. So the accelerometer is going to be used for a dead reckoning system, which is used for localization in robots. Localization is very important if you want to build a map. So what we're going to do is we're going to use the accelerometer to make sure that we are actually moving. So the very first thing that we want to do here is not really sure. I really think that what we want to do is solder this up real quick. So the way we're going to solder this up is, this is going to be the outward facing part of the board. And we're going to take this guy and we're going to stick it in the back where the actual labels are at. Okay, so I'm going to go ahead and solder this, and then we will continue with the tutorial, which is not really about soldering and it's not really about this device. It is about I2C devices in general. So let me go ahead and stop this and we will get to work. So I'm back. That was pretty easy. I didn't take you with me, but that was pretty easy. All we did is we soldered this on this chip. Now that we got that there, we probably should have pushed it down a little bit because it's not a perfect solder, but it worked for what we needed. Like I said, this is the accelerometer. We're going to put this to the side. Alright, now what I have here, I'm going to just grab the camera real quick and try to show you. What I have here is my Arduino. Alright, and I have what I told you was the GY26. Okay, first arrow that we have here, you'll notice your arrow. You can find all this on the data sheet if you Google that, which let's just go ahead and do that real quick. One of the most annoying things that I've ever found on tutorial videos is that they just assume you're going to know everything. So let's do, let's see, GY26, there we go. That's what we need. There's calibration issue, so let's just do this right here. GY26 compass. Alright, so here we go. Here's some information about this thing. Alright, so there you go, you see it. That's what we have there, exact same thing. Okay, there's the arrow that you see on the screen. Let's go ahead and take a look down here. It's going to give us our pinout somewhere. Okay, it gives us our pinout and it tells us exactly what we need to do. So we got voltage hooked up to 5 volt. We got the SCR, which is the clock for the I2C communication that's hooked up to Arduino pin 5 on the Arduino Uno. Now, notice this is only specific for the Arduino Uno. If you're going to use something like the Arduino Yen or the Arduino Mega or the Mega 80K or the LilyPad or something like that, you're going to want to check the specifications for that particular board and find out what your SCL and SDA input pins are, what the analog pins are for that board. So then we have the SDA that goes to analog pin 4 on the Arduino Uno, and then lastly we have the ground. Okay, so that guy's hooked up. That guy's already hooked up. Alright, so this guy's hooked up. Now, you can go somewhere. Let's see. Here we go. You can look at this link right here. Alright, basically, how did I find this link? I don't know, but if you look, it's at play.arduino.cc. Here's the link right here. Check it out. I'll list it for you here. Link for I2C Test. Alright, so there's a link for the test. Basically what you're going to do for the test is pretty simple. Okay, so if you look here on this test, there's basically just going to be some code. That's what we want to do. We want to check out that code. What this is basically going to do is it's going to scan your Arduino, it's going to scan the I2C line, and it's going to check to see if you have any I2C devices hooked up. Luckily for you guys, I have went ahead and done this already. It's pretty simple. Just come down here, hit get code. You get the code. Here's your code. Control A, Control C. Go to Arduino. File, new sketch. Control A, Control V. And then we want to make sure that we have an Arduino Uno board hooked up and we're on COM 6. So we are going to load that. To our machine. Okay, so we're basically uploading that to the Arduino. Now we've got it loaded to the Arduino, so let's see. Control Shift M, here's our serial monitor. Serial monitor is going to tell us what we're scanning. We found I2C device at address 0x70. That's a hex address, okay? That is a 6-bit address. How do we know that? Let's check it out. Let's go to our calculator. Don't have one here. Calculator. And let's look. Edit. Let's go to View. Let's go to Programmer. Let's check out hex here. And it says 7070. Let's change this to binary. We've got 1, 2, 3, 4, 5, 6, 7. Automatically 7 digits. If we want to call that decimal, we're going to call that 112. And I've already tried that and I had an issue here. So, let's do a new sketch. Okay? For this new sketch, we want to do include wire.h. Alright? And let's do wire.begin. And let's load this to our board. I didn't want to do that. I didn't actually want to load it to the board. I really just wanted to compile it. Compiled fine. Okay. So we're going to do wire.begin transmission 0x70. Bam. Okay. So there's that. We've uploaded that. Let's check again. It does find our device at 0x70, which is great. Okay, hopefully you're able to see that. We don't need all this anymore. Okay, so now what we want to do is we want to look. Boom, boom, boom. Here we go. Here's some more information here. It's going to give us some information. Now, if you notice, this is just the actual data sheet for this particular device. Alright. I realize you can't see me. And who cares if you can see me, right? You just want to figure out how to do some stuff with I2C communications. So, there we go. Maybe that will work. Who knows? Does that work? Sure, works good enough for me. Alright, so anyways, we got some information here. It's going to tell us, here's if we're going to use I2C. Alright, so commands, blah blah blah. Oop, blah blah blah. Alright, so we want to send. Alright, so we want to send these commands right here. So we're going to do wire dot send 0x00 wire dot send 0x31 wire dot in wire dot, let's just do request from, and then we're going to do 0x70, and we want to request, let's say, 3 bytes. Okay, and let's do for int I equals 0, I less than 3, I++. Let's just do serial.print line wire.read. Alright, let's start a serial monitor up here. (9600) baud rate. Okay. And then let's do a wire.end transmission. Wire.end transmission. Alright. Let's send that guy. Wire has been renamed wire.write. Alright. There we go. Compile that sketch and let's see if we get anything on our serial monitor. Alright, so we are actually, there we go, we're getting some information. Alright, let's do a delay here. Let's see. Delay 1 second. Alright, let's send that guy back there. You can see this is a fairly simple program that we have right now. At least we're able to get some information here from our I2C device. Alright, so here we go. Open up our serial monitor. Now we've got some information, okay? Now, look at that. Okay, information's changing. Looks like the 9 is the z-axis. Nope, definitely not the z-axis. So, now we need to figure out how to get these bytes of information into some useful format, okay? And you can see, check it out, you can see what's on the screen, and you can see, let's do this real quick, alright? Just so we can, alright. Now we can distinguish what's going on here and see the 3 different data values separated in between our lines. Alright? So that's done uploading. Let's start a serial monitor. Now we see what's going on. Those are 3 separate values. Okay? So we can move this. Alright? And you see our values moving. We get a 127, 87, 76, 56, 12, 241. Alright, so we're definitely getting different values. So we're getting some information from our compass. Alright? Great. Awesome. Got some compass information. What does that mean? Well, really, that's up to you to find out, okay? So we can figure out, according to our data sheet, alright, according to our data sheet, blah, 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 when using I2 compass, blah, 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 communication very simple, the address, blah, 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 first byte, second byte. Alright, so there's 8 bytes, lower 8, so we need 4, 3, 2, and 1. Alright? So I think that's where the 0 is coming from. Let's take a look. Alright? Let's look back here. We get a 0 every time, right? That 0 doesn't change. Nothing we can do to change it. Alright, so basically that 0 that we see there. I hit the button. See how long this video is getting because I don't want it to be too long. 11 minutes. We're going to give it about 10 more minutes and then hopefully you have a good idea of how to get some information from here. And then we can go from there. If there's any type of comments or anything, I can give you more detailed information on how to actually get some useful information from here. But this isn't really a tutorial about this compass. This is more a tutorial about I2C communications. And as you can see, we are getting information from the I2C line or I2 line, I2C line from our compass to our Arduino. Great. Alright, so basically what we want to do now is we want to change this to blah 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 blah. Let's get 4 bytes. Alright. Actually, you know what? Let's get 8 bytes. Let's get all 8 bytes of the information. Alright. So there's 8 bytes of information. We're going to change that to 8. We're going to send this back here. And why are we doing that? Because you look right here, it's giving us 8 bytes. First byte's not being used. Second byte gives us the high 8 bits of the angle. Gives us the low 8 bits of the angle. Gives us the high 8 bits of declination angle. Low 8 bits of declination angle, not being used, not being used. And the last one is the level value calibration. Great. So let's take a look here. We got that. That's done uploading. Bam. Let's see what we got. There is our 8 bits. Alright. So the bottom one should change. Well, I would have thought it would change. Doesn't change. I guess the lower, I guess the elevation is something that we're going to set. So it looks like the only thing that is going to change is second byte, third byte, and the fifth byte. Alright? .255 is not actually changing that much at all. Looks like the 255 is staying pretty constant. The 211 and the 10 looks like is what's changing. Okay, so second and third bytes what's changing. Everything else looks like is remaining pretty constant. Okay, so we are getting all 8 bytes of information from this guy. Alright, great. So, let's look at, what's this called? Let's look at the blah 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 GY45. GY45. Let's see if we can find a data sheet for this. Blah blah blah. Let's see if we can add accelerometer to it. Well, we don't want a tutorial. We don't want no tutorial. Alright, here we go. GY45. There we go. It looks like exactly what we got. Now, do you give me a link to a data sheet here like a good place would? No way, Jose, you sure don't, do you? Alright, so let's go to the next guy. Do you give me a link to data sheet? Give me a link to data sheet? No, you don't. No, you don't. You sure don't. Alright, let us look at the next guy. Do you give me a link to a data sheet? Customer reviews, blah 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 blah. No data sheet. You know what? So let's just add this here. Data sheet. Alright. So I do not see a data sheet. I do not see a data sheet, which my robotics professor is not going to be happy about. Because, why? Well, because I bought this without. So I wonder if there's a different name for this. Let's check this out. There is another name on here, and it is MMA845X. Can we get a data sheet from that? Sensor, toolbar, accelerometer board. Blah blah blah. Here we go. Here we go. Looks like something cool here. This is a data sheet. Data sheet. Data sheet. Data sheet. Data sheet. Check it out. Check it out. Check it out. Hopefully this is going to be the data sheet. Nope. Does not look like it. Definitely not it. Definitely not it. Alright, so we'll have to do some research on the data sheet, which is something that, you know, you just really have to do yourself. Looks like maybe this could be it. Do you want to give me a data sheet? No, you sure don't, do you? Alright, so you're out of luck on this tutorial. I don't have a data sheet for that. We did get one device set up for you. And the main thing here is you learn where this program's at, which I'm listing in this link right here, okay? And with this program, you can hook up any I2C device. So, for example, I could hook up my Raspberry Pi here, and I would if I had some female jumpers. I would hook up my Raspberry Pi, and we could see that there is an address for the I2C device. So these two I2C devices, which let's go ahead and do that. Alright, let's go ahead and check out. Alright, let's take this out of here real quick. And just before this tutorial is over, we're going to go ahead and do this for you, just so you can see. Now remember, this address for this compass or magnometer, the GY26, that address was hex 0x70. Alright, that was our address for that. So now let's hook up this guy, and let's just remember where everything goes. First one is the voltage. We're going to give it 5 volts. Second one is third one is the ground. The other one's a 3.3. I don't really understand what the 3.3 is. And then let's see, what else do we have? Next one is the SCL, which I'm pretty sure is 5, right? Yep. SCL is 5. And then we got the SDA, which is 4. Alright. And I'm just getting that from the back of there. It tells me right there what the pinout is. If we had access to the datasheet, I'm sure the datasheet would tell us. Alright, so now let's load this to our sketch. And we're going to look, and it's saying right here it's uploading, blah blah blah, uploading. Bam. Did we find something? Yep, we found an I2C device at 0x1c. So hex 1c, that is also going to be a 6-bit address. We can find out by going to hex in our calculator and doing 1c and changing that to binary. Here we go, 1, 2, 3, 4, 5. Change that to decimal, and that's address 28. So we can see that our program is actually locating the I2C devices for us. So it's giving us the address, and we're going to use that in our other program to do our wire.begin. We're going to do the wire.begin with the address, whatever is given to us from the test program. Okay, so hopefully you have a better understanding of I2C communications. If you don't feel bad, because this was only a 20-minute tutorial, and I2C is a very lengthy protocol. It's not the easiest thing to understand, especially if you are not a senior computer engineering major like me. For me, it's pretty simple to understand. So if you have any questions or concerns, you know what to do. Leave a comment, send me a message on Facebook, give my cell phone a call. If you do that, I'm not going to answer. But, you know, leave a comment, friend me on Facebook, do whatever, look at somebody else's tutorial, or use Google, because that works pretty good. So, like I said, I'm Jim Vaughn. Really appreciate you watching my YouTube channel or watching my videos on Facebook. That's it. I'm going to go back to build my robot.